So in section 1.3, we ended up coming to this system of equations and not knowing really what to do with it. So in 5.1, we're going to learn how to solve the system. I wanted to go ahead and give you the answer to it. It should be 6,000 in bonds and 5,000 in stocks. So once we learn 5.1, come back to this system and see if you can solve it for the right answers. All right, so this should be a little bit of a review. You should have covered this in probably Math 116. And so 5.1 says a system of linear equations in two variables. We're going to review this because to be able to solve a system with three variables, you definitely need to know how to solve a system with two variables. So let's just make sure we understand what it means to be a solution. If I ask us, do you want a solution to this system? System just means you have more than two or more equations. When if it's going to satisfy and be a solution, it has to satisfy both of the equations. So if I plug in a 3 and a 1 there, I get 3 plus 1 is 4, so it satisfies the first equation. And if I plug in a 3 and a 1 there, 3 minus 1 is 2, it satisfies the second equation. So 3, 1 is a solution. Now these are just lines. This is a line and this is a line. So how are we going to be able to understand if it is a solution? How can a point lie on both lines? Well, there's three different possibilities. For a system of linear equations in two variables, so again linear, we're going to have lines, two variables, just x and y, but we're going to move into three variables in the next part of this chapter. Exactly one of the following is true. One possibility is you have an answer. So one possibility is you have one solution. And if you have one solution, all that means is you have intersecting lines. So the only way that a point can satisfy both lines is if those lines intersect. And so that's one solution. But there are two other possibilities. You could have no solution. How would you have no solution? Well, you have no solution if you had parallel lines, because those lines would never intersect. So if you had parallel lines, you would have no solution, because there would be no point that would satisfy both of those lines. And the last possibility is if you had infinitely many solutions. Now how could you have infinitely many solutions? Those are called coinciding lines. And coinciding lines means you have a line and the other line lies right on top. So then every point on the blue line also satisfies the red line, so you would have infinitely many solutions. So you could have three different possibilities. One solution, they intersect. No solution, they're parallel. And infinitely many if they land right on top of each other. So just a little bit of definition. If you have at least one solution, your system is said to be consistent. So take a wild guess. No solution, the system would be inconsistent. So if you have a solution, you're consistent. If you don't have a solution, you're inconsistent. So now if you have only one solution, your system is said to be independent. But if you have infinitely many solutions, the system is said to be dependent. So just a little bit of definition and terminology you might want to know. So back in 116, you learned how to solve systems of equations by graphing, which we're not going to do at this point. The elimination, which is also called the addition method, and the substitution method. So instead of reading this to you, I'm going to just go ahead and write in what should go in the blanks. I'll let you read it on your own. So first thing is, if you want to use the addition method, you want to differ only by a sign. You'll add to eliminate one variable. You'll solve, and then you're going to make sure that you check that your answers work in all of the equations. If you want to try the substitution method, you're going to solve one equation in terms of the other, substitute one of the equations into the other equation. That'll give you one variable only, and then you can solve. And then you will back substitute to find the other variable, and then check to make sure that your solution satisfies all of the original equations. Whenever you check, always go back to the original. Now the great thing about this is these answers should work, so if they don't check, either your check stage is wrong or your solution is wrong. So you will definitely know if your answers are correct before you turn in your test. All right, so we're not going to do all of these, but I will do some, and then I'll circle and give you the answers, and you can try some on your own. So let's go ahead and do number 1. It says solve the system or show that it has no solution. If the system has infinitely many solutions, we're going to express using set notation. Now in chapter 5 we learned set notation. In chapter 6 we learned something called a complete solution. So make sure you know the difference between a complete solution and just expressing them using set notation. So let's go ahead and do number 1. If I want to do substitution method, I'd like one of my variables having a coefficient of 1 and I don't. So I'd rather do the addition method when I don't have a coefficient of 1. So with the addition method, we decide which variable looks easier to eliminate. Well, they have to be the same number but differing by a sign. So the easiest way is to make this become a 6 and a negative 6. You could eliminate the y's, but this should be had to 55, and that would have to be a 55. So a little bit larger numbers, but you could certainly do that. So to make the x's become the same number but differing by a sign, I would multiply the first equation by 2, and I'd multiply the second equation by 3. Since one's already positive and one's already negative, I don't have to worry about multiplying by negative. When you distribute your 2, make sure you go all the way across. So I'm going to end up with 6x plus 22y equals 8. You're going to do the same thing with the 3. Make sure you distribute all the way across. So you get a negative 6x minus 15y, and 3 times 9 is 27. Now the reason why we do these steps is because now if we add the two equations together, one of your variables should be eliminated. You know you've done something wrong. So when I add these together, my x's go away. 22 minus 15 would give me a 7y, and 8 plus 27 would give me 35. So if I divide by 7, I know that y is going to be 5. So in my ordered pair, I have a y being 5. Now I also need to still find x. So where should I go back to find x? You can substitute it in either into the first equation or the second, because it should satisfy both. I'm just going to plug it into the first. So I get 3x plus 11 times 5 is supposed to equal 4. So I get 3x plus 55 equals 4. Subtract over the 55, so 3x is going to be equal to negative 51. Divide by 3, so x equals a negative 17. Make sure you write it as an ordered pair, because you have found where those two lines intersect. So if by chance I would graph these, I would see they would intersect at negative 17, comma 5. All right, so I'm going to do number 2, 3, and 4, and you're going to try 5 and 6 on your own. All right, so let's look at number 2. Again, I'm going to show the other method, which is the substitution. Substitution method says get one of the variables by itself. So I'll get x by itself, and all I'll do is subtract over the y. And then I'll take whatever I found x to be, and I'll plug it into the second equation. So I get 2 parentheses 7 minus y minus 3y equals negative 1. I like doing this method if I had coefficients of 1, at least one of the variables having a coefficient of 1, but like on the first one, since I didn't have coefficients of 1, addition method works a little bit nicer. Distributing my 2, I get 14 minus 2y minus 3y equals negative 1. Combine like terms, I get a negative 5y. Subtract over the 14, I get a negative 15. So y is going to equal 3. So in my ordered pair, I know y is 3. Again, where should you plug it back into? Well, it doesn't matter because it should satisfy all of the equations. I'll just plug it into the first one. So x plus 3 equals 7. So then x would equal 4. Now before I go on to the equations, I should make sure that the answers work. Well, 4 plus 3 is 7. 2 times 4 is 8, and 3 times 3 is 9, and 8 minus 9 is negative 1. Same thing on the first one. You should check negative 17 and 5, plug it in, you should get a 4. Plug in negative 17 and 5, you should get a 9. So definitely check your answers. So right now for number 1 and 2, we see that they intersect at one point. All right, so let's look at number 3. We have negative 3x plus 5y equals 2, and 9x minus 15y equals 6. Since none of them have a coefficient of 1, I would go ahead and do the addition method. So I would think about what do I need to multiply by to make either the x's be the same number differing by a sign, or the y's. The x's I can see if I just multiply the first equation by 3, my 9's will be differing by a sign. So I'm going to distribute my 3. I get a negative 9x plus 15y equals 6, and the second equation stays as is. Again, why do you do that step? Because if you add the two equations, hopefully one of your variables cancels. Well, in this one, your x's cancel and your y's cancel, and you're just left with a 0, no variables at all. And 6 plus 6 is 12. Well, that's definitely not true. So when all your variables cancel, you either have no solution or you have infinitely many. But this one, this is no solution because this is not true. So this would be no solution. Now, what does that mean about these lines? These lines were parallel. Lines were parallel. So if I took time to graph them, I would see that, well, they'll never intersect, so there can't be a solution. All right, so on number 4, we have fractions. So one thing you can do, because you have an equal sign, is get rid of fractions. And so all we got to do is multiply by a common denominator that's going to get rid of my denominators, which are 3, 6, and 3. So I could multiply everything by a 6. If I do so, I can cross cancel or multiply straight across and then reduce. Either way, you get a 4x plus a y equals a 4. And the second equation stays as is, 4x plus y equals 4. If I multiply one of them by a negative and add it together, I'll see that my x's cancel, my y's cancel, and 4 minus 4 is 0. So this is true. Your variables completely disappeared, but you have 0 equaling 0. So what this means is you have infinitely many solutions. Now, because you have infinitely many solutions, make sure what it said to do. Express them using set notation. So I'm going to have to use set notation. Well, if you remember back how we wrote set notation, we said the set of all, and normally we would just say x. But we have two variables, and we're looking for the ordered pair. So it's the ordered pair xy. We draw the line down such that, and then we write either of these equations because they're the same one. So if you want to write the first equation, go ahead. I'll go ahead and just write the second equation. So if you have infinitely many solutions, in chapter 5, they're going to want your answer in set notation. In chapter 6, they're going to want a complete solution. So make sure you know the difference. So I'll give you the answers to 5 and 6. Again, you should know if your answers are correct because you will check your answers. But on number 5, it should be -3 and 2. And number 6 should be 2 and 6. So make sure you can do those, either substitution or the addition method. Number 6 is actually already set up for you in substitution, so I probably would use that. But I would like you to get really good at doing the addition method. All right, so we do have a few word problems as well with chapter 5.1. And all I'm going to do is set them up and then give you the answers, and you can solve them on your own, again using the addition method or the substitution method, whichever method you prefer. So the sum of two numbers is twice their difference. The larger number is 6 more than twice the smaller. Find the numbers. So first of all, we have two numbers. We're going to let x equal, we'll say the larger number, and y will be the smaller number. It doesn't matter which one you say, but just make sure you label which one's which. So we know the sum of two numbers, sum means to add. So we're going to have x plus y. Is the equal sign, twice their difference. Twice the difference, and their difference is subtraction. So 2 times x minus y. This does not look like what we've done in our previous problems because we have variables on both sides. So let's fix this a little bit. Let's go ahead and distribute in our 2. So we get 2x minus 2y. And then if you want to bring everything over to the left or everything over to the right, that's fine. But we're trying to set it up to look like what we had in the previous section or previous problems. So I'm just going to subtract over the x, subtract over the y, and I'm going to get 0 equaling x minus 3y. So x minus 3y equals 0 will be my first equation. Now, I also need a second equation. The larger, which I said was x, is 6 more than twice the smaller. So the larger x is your equal sign, 6 more than twice the smaller. So twice the smaller, and then 6 more than that. So 2y plus 6. So again, it all depends on which one you said was the larger and the smaller. I just said let x be the larger. So our other equation would be x equaling 2y plus 6. This is already set up for you in substitution, so you could do a substitution, or if you want to do the addition method, feel free to do so. So we end up with a larger number is 18, and the smaller number is 6. So make sure you can solve that either by the addition method or substitution method. All right, number 2. A hotel has 200 rooms. Those with kitchen without kitchen facilities rent for $80 per night. On a night when the hotel was completely occupied, revenues were $1,700. How many of each type of room does a hotel have? We have 2 different kinds of rooms. We have rooms with kitchens, and we have Y equaling rooms without kitchens. So because we have 2 variables, we're going to need 2 equations. First equation says that a hotel has 200 rooms. Because I have x plus y being the number of rooms with kitchens and the number of rooms without kitchens, those are the only kinds of rooms, so x plus y would equal 200. The cost equation says the ones that rent for $100 per night are those with kitchens. Ones without kitchens rent for $80 per night. And on a night when the hotel was completely occupied, the revenues were $1,700. So 100 per the night per each room with kitchens plus 80 times the ones without kitchens should equal the 17,000. Now if you like that equation, you can go ahead and write it over into your system. But sometimes you want to make your numbers a little bit smaller. So you could divide everything by possibly 10, maybe even something a little bit more, but at least we do see that there's a 10 in common. This is not a necessary step, but it does make your numbers a little bit smaller. So I get a 10x plus 8y equals 1,700. Now if you look at that, there's still a little bit larger number we could have divided everything by. You could have actually divided everything by 20, but we just divided by 10. So again, sometimes it's just nice to make your numbers a little bit smaller. So when you solve this one, you should get 50 rooms with kitchens and 150 rooms without kitchens. So what I'll be looking for is that you label your variables, you have 2 correct equations, you show your work, and then you box in your answer. Alright, so this is always a fun one, number 3. When an airplane flies with the wind, it travels at 80 miles in 4 hours. Against the wind, it takes 5 hours to cover the same distance. Find the plane's rate in still air and the rate of the wind. So this kind of should sound a little bit familiar with those boat problems upstream and downstream. Now we're just dealing with a plane. So we're going to let x equal the plane's rate, which just means its speed, and y is going to be the wind speed or the wind rate. If your plane is flying with the wind, it helps you go faster. Against the wind, kind of slows you down. So when an airplane flies with the wind, it travels 800 miles per hour in 4 hours. So let's remember what the formula is for distance, rate, and time. Distance equals rate times time. So we have with the wind and we have against the wind. So with the wind, the distance was 800. The rate, we're going to take the rate of the plane and add the rate of the wind because it's going faster when you go with the wind. And we know the time that it took was 4 hours. So the distance, 800, equals the rate times the time. The other equation is going to be against the wind. So against, it takes 5 hours, but you're covering the same distance. So the same distance is still 800. It's not going to be x plus y, it's going to be x minus y, because you're going to take the plane's rate and subtract the wind rate because it's slowing you down. So making this look a little bit better, we could distribute in the 4. So we have 800 equals 4x plus 4y. If we like the way that equation's written, I could flip the 800 over to the other side, or we could divide everything by 4 to make our numbers a little bit. So x plus y equals 200. Again, that's not a necessary step, but it's a good habit to get into to make your number smaller when you're solving. This one would be 800 equaling 5x minus 5y. Again, it would be a good idea to divide all of those by 5 to make your number smaller. So x minus y equals 160. So if you want to go ahead and solve that by either substitution or the addition, I would definitely do the addition method because my y's would go ahead and cancel, and x plus x is 2x. So you'd get your answer pretty quickly. But we do know that the airplane is going 180 miles per hour and the wind is going 20 miles per hour. So the airplane rate is 180 miles per hour and the wind rate is 20 miles per hour. So again, try those and see if you can get to the right answers. And if you have questions about solving, just let me know. All right, so the last one is number 4, and this is probably the newest one out of them all. The other ones we should have already seen a little bit. But it says a company manufactures bicycles that has a fixed cost of $100,000. What's a fixed cost representing? Well, it's salaries, your electricity, all kinds of bills, those kind of things. So you have a fixed cost no matter what. And it says it costs $100 to produce each bicycle, and the selling price is $300. So they want a cost function, they want a revenue function, and then they want to know where you can break even at. So part A, the cost function, C of x. What is x going to represent? X is going to represent the number of bikes. All right, so our cost function says, well, what cost do we have? We have a fixed cost of $100,000. No matter what, we have $100,000 part of our cost. We also have a cost of $100 to produce each bicycle. So plus 100 times x, the number of bikes we're producing, times 100 would give us our cost. And that's our cost function. Now our revenue function says, well, how much are you selling them for? You're selling them for 300. So our revenue, R of x, is going to be 300 times x. Why? Because each cost we sell, for each bike we sell, we get to sell it at 300, so 300 times x. And then the last part, part C, says we want to know, determine the break-even point. So the break-even point is when my cost function would equal my revenue function. So we're going to set the cost equal to the revenue. So my cost is 100,000 plus 100x, and my revenue is 300x. So just subtract 100 and divide by the 200 when you get it x by itself. X is going to equal 500. Now some students think that's the break-even point. That's just the x value. The break-even point is when you plug the 500 back into either the revenue or the cost. And that would be 500, comma, 150,000. That is the break-even point. What does that actually represent? What does that mean? Well, that means you have to produce and sell 500 bikes to break even. And your cost and your revenue are equal at 150,000. So when I ask you to explain something, I want you to take apart your break-even point. So you had to produce and sell 500 bikes to break even, and that means your cost and your revenue would be 150,000. So that's it for the word problems. Try and solve those and make sure you get those answers.